More than 25 centuries ago, among the Greek islands, here at the vibrant crossroads of Africa, Asia, and Europe, philosophers began to devise rational theories about the world around them. The wondrous waves and forms of nature, they said, could be understood. One Greek thinker suggested that the Earth actually moved around the sun. Another taught that everything, the work of man and nature, was made of particles too small to see. Others estimated the sizes of the Earth and the Moon and the distances between them, and reasoned that both were spheres. But it would be many centuries before we had the tools to extend our vision and confirm the wisdom of these early thinkers. In the meantime, people around the world gazed on the stars and gave them names. Most assumed that the Earth was the center of an unchanging universe. "2,000 years passed before a revolutionary breakthrough was made by a mathematics professor in the ancient maritime republic of Venice. In 1609, Galileo Galilei demonstrated an instrument that would soon be called the telescope. From the tallest bell towers, he showed that this device could spot approaching ships hours before their sails were visible to the naked eye. Later, when he aimed his telescope at the night sky, Galileo discovered that the moon was a world with mountains. Jupiter had its own moons, and the Milky Way was a band of countless stars. Our own cosmic voyage begins here, in the center of Galileo's Venice, St. Mark's Square. Since the universe is a big place, we could easily get lost. So we'll need signposts to give us a sense of scale. The acrobat's ring is 1 meter wide. The crowd is 10 times wider, 10 meters across, larger by 1 power of 10. Now, with every step, every ring, we travel 10 times farther from Venice, and our view of the universe is 10 times wider. The 100-meter ring surrounds St. Mark's, and 1,000 meters, 1 kilometer, the city center. As our speed increases, 4 steps, 4 powers of 10, reveal all the islands of Venice, the Adriatic Sea, and the mainland of northern Italy. Six steps take in Europe from central Germany across Italy to the Balkans. And soon we can see the entire planet, our home in space. It's not a star, but an entire galaxy, composed of countless stars. Astronomers have discovered that the galaxies are flying away from one another, The universe is expanding. Our own galaxy and all the others form clusters and superclusters of stupendous size, hundreds of millions of light years across. And here, about 15 billion light years from Venice, we approach the outer limits of the visible universe. What lies beyond this cosmic horizon, we cannot see and do not know. While Galileo's telescope allowed us to take an outward voyage, another innovation here in the Dutch town of Delft would lead us on an inward journey of discovery. Over 3 centuries ago, Antony van Leeuwenhoek perfected the early microscope and used it to study droplets from the waterways of Holland. As students today make their own discoveries, imagine the moment when Van Leeuwenhoek peered through his more powerful instrument and discovered a living kingdom in a drop of water. This busy world of single-celled paramecia is only 1 millimeter across, 3 powers of 10 smaller than a meter. The microscope allows us to continue our journey into the realm of the very small. As we move into the cell nucleus, each new ring now reveals a world 10 times smaller in diameter than the last. Deep within the nucleus, we come upon truly remarkable constructions, long spiraling molecules of DNA. DNA holds the chemical codes for the reproduction of most organisms on the planet, whether they're paramecia, people, or petunias. Voyaging on, we see that molecules are made of even smaller parts called atoms. The tiny world of the carbon atom is very strange indeed. Its 6 electrons seem to swarm everywhere at once. Now our voyage takes us through a void that appears as vast as the space between the stars. Ahead lies the atomic nucleus, so fantastically small that if the whole atom were the size of this theater, its nucleus would be like a speck of dust. Yet the nucleus contains almost all of the atom's mass, packed into particles called protons and neutrons. And these, in turn, are made of still smaller, mysterious things called quarks. Exploring this, the inner frontier of the universe, physicists wonder if quarks might contain even tinier building blocks of matter. Scientists are investigating this mystery in an underground tunnel near Chicago, home of the giant Fermi-Lab particle accelerator, designed to create conditions like those that existed just after the birth of our universe. Millions of protons and antiprotons race through these pipes in opposite directions, nearly at the speed of light in a kind of subatomic demolition derby. Now, our cosmic voyage enters another dimension, the dimension of time, where knowledge is much less certain. Studying traces of quarks from these collisions, physicists try to learn what our universe was like when it began after the explosion known as the Big Bang. One of them outlines the theory.
Welcome to Fermilab. Today, astronomers see the universe expanding. Imagine running the expansion backwards. Billions of years ago, everything must have been packed together at enormous density. It seems incredible, but we think that the matter making up everything we see in the universe today, everything, the buildings, trees, people, planets, stars out to the most distant galaxies, was once crammed together into a volume smaller than this. And then,
space itself exploded in a burst of radiant energy. In those first dazzling moments, the newborn universe began to expand and cool. Quarks combined into protons and neutrons, which later attracted electrons to form atlae.